Are you trying to learn and master the data analytics tool, Microsoft Power BI? So welcome back to Excel Island, where we're trying to learn and master Microsoft Power BI over the next 100 days. Today is day 29. I'm super excited. Yesterday, we started a new course, which is data modeling in Power BI. And the goal and objective of this course is to learn and master data modeling, which is the backbone and foundation of every data analysis before you start creating reports. The goal of this data modeling course is to learn how to create snowflake or star schema data models, which is one of the best data models to create before you start even analyzing or slicing or dicing your data. So yesterday we started the course. We've covered chapter 1 in the course data modeling in Power BI. We're moving to chapter 2 of the course today. So without further ado, let's get back to learning. We have a lot to cover. Also, all dataset exercise files, Power BI files that we'll be using to learn and master our Power BI over the next 100 days is already linked under the YouTube description. Do make sure to download those files and practice along with me. Without further ado, let's jump back to learning. Welcome to day 29. So basically, we just continue from where we stopped yesterday. Or if I take a quick guide to the career track on DataCamp, which I always do before I start. We've covered data analysis in SQL. That was the first live stream I did while trying to learn and upskill myself as a data analytics expert. Also, we've started this data analysis in Power BI. We are 36% through the whole career track, and today is day 29. So we're kind of faster with the career track compared to the days. So also, we are moving to data analysis in Python after completing this data analysis in Power BI. So you definitely want to subscribe right now to the channel and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. Also, we're going live for the next probably 200 days because we're starting data analytics in Python also for another 100 days. So probably throughout this year, I'll be sharing more, like I'll be doing more live streaming section compared to uploading personal videos. But I'll also try to upload videos. I'm working on a lot of projects behind the background, which I would like to share with you also. So make sure to subscribe right now when I drop those videos to the channel. So let's continue with the data analysis in Power BI career track. So we have 17 courses estimated for 48 hours, and we've covered 6 courses. We've covered 6 courses so far. We are on the 7th course, and today is day 29. So let's continue with the course. So I'll just put on my headset real quick here. So I think this is the chapter 2 of the data modeling part of the course. If we've covered this chapter 1 yesterday, defining tables, it was quite an interesting chapter to cover. So do make sure to watch day 28 live stream to understand all what we did here. So let's continue with this day 28, day 29 live stream rather, which is shaping tables. So welcome to day 29.
In this second lesson, you'll learn about database normalization and table operations. Database normalization is a set of rules and processes for data modeling. You could say it's similar to organizing or designing a database. Normalization has a few key goals. First, we want to remove redundant data. That is, when the same information is stored in multiple places. Reducing redundancy can shrink down file sizes and avoids data inconsistency. The final goal is to build out a design which reflects the real world as it is, including how business entities interrelate. As a result, the data is separated over several tables and are connected through relationships, a link from one table to another. Relationships are defined in Power BI. Power Query includes several data shaping operations to get closer to a normalized data model. We'll cover 4 techniques for shaping data: splitting columns, extracting values from columns, merging together queries, and appending queries to one another. Note that all of these are always performed in Power Query. These are the most common practices, but not the only ones possible. Column splitting breaks one column out into multiple columns based on split criteria. It could be after a delimiter, such as a comma or tilde. For serial numbers, we might split after a number of characters, for instance, the first 5 characters representing the brand and the next 3 the product. In the example on the slide, you notice 3A got split into 3 and A. Column extraction takes columns from one table and breaks them out into multiple tables. When extracting a column, we can define keys for the new tables. A key is a column or set of columns which make a particular row unique in a table. On the original table, we retain that key column so we can create a relationship between the tables. In Power BI, you can define these relationships in the model view. With column extraction, we retain just the distinct values of these breakout tables, which shrinks the total data model size and reduces redundancy. You can append a query to combine the contents of two or more tables into a single table. It matches rows based on the column names, so watch out for differing headers. It's equivalent to a union all statement in SQL. Query merging is the last option of how you can shape data in Power BI. There are different ways to join tables together using keys, and it is very similar to joining tables in SQL. Don't worry if you're not that familiar with this. It's covered in detail in other DataCamp courses, but it's good to know this option exists. I'll see you in the instruction demo.
So we understand what we need to do here. So it says Power Query versus Power BI again. Some of the actions and operations for proper data modeling exist in Power BI itself. Others exist in Power BI Query. Still others are important but do not have simple functions or user interface options. But to drag the data modeling operation to the correct buckets is the action performed in Power BI or in Power Query. So query appending are definitely in Power Query. Create relationship, do that in Power BI. Query merging, Power Query. Create visuals, Power BI. Column splitting, definitely Power Query. Let's submit that. We nailed it. So seems like you are ready for shaping tables in Power BI. Having a good understanding of where you can perform different data modeling steps is crucial when loading and shaping data. So let's continue. So let's learn about merging and appending queries. I think we covered this also when we like to do introduction to data transformation in data preparation in Power BI. You will learn merging and appending.
Let's have a look at some table shaping operations in Power BI. This time, we only have our datasets split up by year and need to append them using Power Query. We'll start with the one from 1978. Selecting Transform Data brings us to Power Query. You can see that the first row is superfluous again, and after deleting it, we can promote the new first row as the head is. To append the second table, select New Source and then Text CSV. This table comes from the year 1979. Select OK, since you're already in Power Query. I need to perform the same operations. Remove the top row and promote the new top row as head is. Now that I've done this, I have two datasets that are actually equivalent. To create a new table with the 1978 and 1979 tables appended, you can select Append Queries in the Combine section, and then choose between Append Queries or Append Queries as New. The former will replace the current table with the appended one. The latter creates a new table where the two tables are merged together. The new table, called Append 1, now contains data from two tables, but you could append as many tables as you want. Let's rename Append 1 to 1978-1979 for clarity. For demonstrating purposes, let's break out establishment age code into its own table. To do that, you can copy this 1978-1979 table by right-clicking and selecting Duplicate. For this new duplicated table, I'll use the acronym EAC and remove all columns but establishment age code and its meaning. This table now contains a lot of duplicates, which you can remove by right-clicking and selecting Remove Duplicates. As a result, the EAC table is now a reference or lookup table. We could remove the meaning of establishment age code in our appended table and use this column as the key to the EAC table. The last thing that I want to demonstrate is how to extract values from a column. There are different options to play with, including ways to extract data based on the number of characters, their position, or a specified delimiter. Suppose we just want to keep the last two characters from the ID column. In the Transform menu, under the Extract option, I'm going to choose Last Characters. Just keep the final two characters and we're good to go. To apply all this and return to Power BI, just click Close and Apply in the Home menu.
Cool, that was it. So let's practice what we've learned so far. So we have three practice to do, three challenges to do: breaking a file into multiple tables, appending files, and column extraction. So the first one says breaking a file into multiple tables. Now, frequently, a data scientist or business analyst will receive a single word file containing a variety of fields. It's often desirable to break out a single table into more structured formats in order to reduce duplication, thus saving space. That you want to reduce redundancy and remove irrelevant data. So in addition, if you are breaking out a reference table from a white table, this can make it easier for certain visuals, such as slicers, to show the appropriate options available. In the next chapter, we will expand on this, but for now, create your own lookup table on NAIC codes. Okay, let's move on. So open the Power BI desktop file, name split table in data science. Let me open the Power BI files. So all files is already linked under the YouTube description. Do make sure to download for practice. Oh, okay, exercises. That is 2.1. Split table. So that is coming up. So I'll read the instruction and go to the Power Query. So duplicate the manufacturing dates table and rename it to NAICS. While it is coming up, it's up. So we are going straight to the Power Query editor. So I need to point to the table. So I'll go to the source right here, edit the source, and just point to the data file, to the file on my local computer, which is the manufacturing data. I'll copy the file path right here and just paste it right there. Click on OK, and boom. So all these steps, I can just walk through it. It's to reapply these steps back to the file. So you cannot perform whatever you want to perform on it right now. So the first one say duplicate the manufacturing data table and rename it to NAICS. I'll just duplicate this table, right click and duplicate. So I'm going to rename it to NAICS. We've done that. So the next step says in the new table, keep only the 2017 NAICS code and meaning of NAICS. Remove the duplicate code from that. So I have to keep only two columns and remove the remaining columns. So if I go to the meaning, I think we are keeping the code 2017 NAICS code and the meaning. I just hold Control on my keyboard. So I want to keep these two columns and remove other columns. So to do that easily without deleting each column one at a time, I'll right click right now and say remove other columns. So I'm going to have only these two columns remaining. So what I will now do is to remove the duplicate code from NAIC. So I'll remove the duplicate code here. Right click and remove duplicates, because you now have unique record here. I can actually, okay, let me delete this step, this remove duplicate step. If I go to the view tab, column distribution, you can see we have 100 indistinct, 0 unique. So that means we have 108 values in this column, but none of them are unique. But if I now remove the duplicates, let me now see. I can see remove duplicates. You can see we now have 108 unique. That means, so before I remove the duplicates, look at this. We have 0 unique, 108 distinct values. Probably distinct, if we can say distinct value or distinct records, that means each line of code is only counting each rows in data sets. It's now. Or let me see column profiling on it. So it's giving us every record. You can see this 3113, 3113. It's going to count it multiple times. That means so unique means those records only appear once. That means unique. So we don't have unique. So immediately I remove the duplicates, I'm going to have what? 108 unique. But the number of rows there is before I remove the duplicate, I think it was over 700 rows. Yes, 700 rows of data here, of record here. Once I remove the duplicates, we're going to have 108 rows. So distinct doesn't mean the record appear once, but unique means the record appear once. But distinct is going to count the total number of records that are in the data set. I think we are good to go. So the next instruction says which meaning of NAIS code is shown on the fourth row of the NAIS table. Which meaning on the fourth row? That should be green and oil sealed milling. The first one. We need it simply but effective. By only keeping the code in your main table, you reduce redundancy, which could improve performance for larger tables. You'll come back to this in the next chapter. So let's move on to the next step. So we want to append files now. So this is the second challenge you want to perform here. So it says sometimes you may receive data sets split into several separate files. A common example is when the data is split by year to reduce bandwidth cost or keep file size smaller. Being able to combine these data sets together allows you to visualize data across those different data sets and present a single consistent table for business users. So you just received an email from a colleague with 3 data sets attached. He was about to append them using Excel, but luckily you know how to do this in a flash using Power Query. So you can repeat the process later when the 3 data sets get updated. So if you lost progress, close any open reports and load. Okay, let's continue from here. Within Power Query, load each of the following files: new data set, time series 1979, 1979, 1980, and 1981. They are located in data sets. So let's bring in those data sets. Right, so we could continue with this. I'll just solve this column distribution information. New source, I think the text of CSV data sets. So want to import all these data sets 1979. Click on OK. You can see there. I'll bring in this a new source 1980. 1980 right here. Click on OK. And the last file 1981. Click on OK. If you notice, let us quickly clean them. You can see we can remove top rows. I want to remove the first row because the data is not clean. We did that yesterday. I want to promote this as the headers. I'll go back here and do the same thing. Remove rows, top rows, use first rows as headers. Finally, for this, remove top rows, one of the rows, the first row rather, and use top rows as headers. So let's go back to the instruction and see what we have to do. So for each of these tables, you just load them. Remove the first row and use the new first row as headers. We did that already. Create a new table called establishment by age, which all of the time series tables appended. So we want to create a new table, establishment by age. So let's create a new table. So I'm going to start from here and append 1980 to 1979, then 1981 to 1980. So it will be underneath each of them. So let's see. So I'll go to the transform out column tab, no, the transform tab, the home tab here, and go to append as new. So I want to create a new table, but these three will not be affected. If I append queries, I'm going to append these two underneath the first one, but I want a new table entirely. If I click on append queries as new, it's going to ask me how many tables do I want. I'm going to select 3 tables. So for this, I want to use 1979, then 1980, I'll add it here, then 1981. I'll add it there. So click on OK. You can see it's going to append them. So for append to work, the tables must have the same number of columns and the columns must have the same data type, or else it is not going to work. So we have to rename this as establishments by age. Establish by age. Let's renew that. Click on OK. Then moving on to the next instruction. Apply the Power Query changes and return to the report view in the Power BI. Hide all separate 19. Okay, we have to hide all this table, all other tables. So apply the change here, close and apply. We're back. Right, so it's going to load all this table. So if I go to the data view here, table view, I should be able to hide this from the report view. I'll click on this eye icon here and hide this. It is hidden. You can see it is hidden. You can see it is hidden. So you are not going to see it in the report view here, but it is still part of. If I unhide this, let me just unhide one of this. If I come back here, you can see we now have it back here. So, but we could just hide that table since we don't need it in the report view. So the next instruction now says create a clustered bar chart visual from establishment by age table. Use the meaning of establishment by age code on the axis and number of employees on the values. So let's begin a clustered bar chart. First, clustered bar charts. This is it here. Clustered bar charts. So we want to use the information, the columns from which table? Establishment by age, meaning of establishment by age code on the axis as axis and number of employees as value. Okay, let's add meaning of establishment by age. This is it. It's code, so I'm correct. And number of employees on the value axis. Where is the value axis? We don't have a value axis there, but the value axis should be the small multiples, number of employees. Okay, we are on track. Meaning of establishment by age. So the code is there. Age code, age code. So which code is this? So it's going to split them into four brackets. So how many employees were hired at firms which had existed for 2 years? So how do you know the code that the firm has existed for 2 years? How do we know that? Let's figure that out how. We couldn't get any information again, but if you had a tooltip, we could just add the year column. Let's see if we have a year column here. Yeah, okay, we have year here, but it's not going to give us more information. Let's see the tooltip. But what I could do is, I could just come a little bit here and add the slicer. What we don't know, if we don't know what the year information is giving us, if I add the year information to the slicer, let's add the year right here. This is 979 to 1980. But the question says, how many employees were hired at firms which had existed for 2 years? How do you know the firm has existed for 2 years? We couldn't figure that out. Oh, so let's read the instruction one more time. It says create a clustered bar chart visual. Clustered bar chart visual. Clustered. This is a clustered bar chart. This is a column chart. This is a column chart. So this is a clustered bar chart. And we have to use the meaning of a submitted age code on as axis. So if I change this to the x-axis, let me see. Let me change it to the x-axis. Okay, we are still going to be getting the same thing, but this time around a barcode. Count of number. See the number of employees. This number of employees. This number of employees. What I could do now is to use the year column on the tooltip here. Let's see. That should answer the question. So with that, I could figure out how many years. So year is going to summarize the years. Oh, so instead of summarizing the year, I could just say so I'm trying to see if I can get it. I want to get okay, what I could do is okay, let's see if we could add the year to the legend. Okay, cool. So we could add year to the legend. I can see this is 1979, this is 1980. So this is the only company, but the instruction says how many employees were hired at firms which had existed for 2 years. We don't even know to know the firms. Oh, could see. Okay, let me see. This is just 1 year. This is just 1 year. 1 year. 7 years. 8 years. Probably the code means the number of years they've existed. If I put 0 there, let's see. That is wrong. Because okay, let me go back to here. Was establishment age code. Oh, I didn't get the instruction. So the establishment age code is the number of is the years that they've established themselves. So how many employee establishment age code 0 years. The age code is probably is 2 years now. Okay, how many employees? Hold up. How many employees were hired at firms which had existed for 2 years? Oh, okay. This has existed for 15 years. Establishment age code 0 years. 1 year. 1 year. One is count of meaning of establishment age code 1. We're having 1 year. We're having 15 years. So trying to get it's quite funny. It's 979. Okay, let's see. Oh, 21. 1 year. Oh, this is quite tricky to get, but I'm going to get even if I'm going to type random numbers. These numbers, number of employees. This is the number of employees that we have here. If I click on the charts, all the number of employees right here. Oh, okay. So I didn't visualize the data pretty well. That was my mistake there. Okay, the y-axis is the age code, the number of years, which was actually counting it, rounding it up the other time. Meaning of establishment age code. If I go back to the data view, let's see. I think we're actually using this table here. Establishment by age. which is showing us the total number of years each company was established. Okay, the number of employees that they have there. So I didn't drop the visuals on the chart pretty well. So I was using the small multiples or tab, which was pretty wrong. So you can see those that have said of 2 years, they just have number of employees is almost 17, 31, 337. That should be 17, 17, 31, 337. Aha, so we got it. But we didn't visualize the charts pretty well before. So this total, I think this is grand total, probably the data isn't cleaned very well. Left censored, 2 years, 0 years, 1 year, 3 years. So I didn't drop my y-axis and x-axis or data point very well. They were using values. They were using on the axis and number of employees for values, but it wasn't stated pretty well. So magnificent. So merging skills. Apparently data set should be a basic skill in your data analyst toolkit. Note that the second largest part of the data is left censored, implying that the data could not be shared or simply not available. Oh, okay, left censored. I mean, data is censored. But it's quite interesting to see. You can see some company didn't even employ number of employees by the years. So I think this is the final challenge we want to solve. That was quite easy to solve. So this is the final challenge on this section, this shaping data tools. So often multiple relevant features will be packed together in one column, or a single feature may have extraneous information. So Power Query has a set of functionalities intended to make it easy to extract values from a column. So the manufacturing dataset contains a column which ranges of percentage of total employees. You realize that it could be useful to split these ranges into their low and high limits, since the company you work for uses only the high limits of the range for their monthly reports. So I think we are continuing with this. So go to Power Query and select manufacturing data table. Navigate to the last column, which should be range indicating percent of total employees inputted. So let's head over back to the Power Query editor. So let's select this manufacturing data and move ahead to this range indicating percent. Okay, we have that locked in. Duplicate the range indicating percent of total employees inputted column twice. So I'm going to duplicate this column. I'll right click on duplicate column. You're going to add it as a copy. Here's the original. So the next one says, from the first duplicated column, only keep the numbers before the first percentage sign. From the first duplicated column, okay, the first one, from the first duplicated column, only keep the numbers before the first percent sign. I want to keep the numbers before the first percent sign. The numbers before it. Let me read that again. Can be confusing. So it says from the first duplicated column, only keep the numbers before the first percent sign. You can use percentage as a delimiter. Okay, keep the numbers before the first percent sign. So transform. Then we go to let's see, extracts. So then we want to use this before the first percent time. So we want to use test before delimiter. So it's going to ask for the delimiter. So I'm going to type percent. So this is before the first percent sign. Let's see. So we have the numbers. You can see. So numbers after, let me go back here. It's going to keep numbers after this first percentage, which is this 30, 30, 30. You can see that. So if I move on to the next instruction, say from the second duplicate column, only keep the numbers before the second percent sign. So this is the second. So we are going to first extract the last 4 characters, then extract again using percentage as the delimiter. So let's see this one. Extract the last 4 character. 1, 2, 3, 4. Okay, so let's extract last character is going to ask, which is 4. You can see if I go back here. So 1, 2, 3, 4, including the space here. Then it now says first extract the last 4 characters, then extract using delimiter using percentage delimiter. Okay, so we're going to do one more thing. We're going to say extract after before delimiter, before delimiter, which is the percentage. Let's see. So we're going to keep the 40, so you can see, but hopefully the spaces are not there again. So we want to change the what? Change the returning column data type to whole number. We want to change this to whole number. So we only changing this I range. So let me just change this I range first. I range total employees. Let's change it to I range total employees. So we have that logged in. So it says we should close and apply. Close and apply your steps and create a new page with a cluster column chart visual. Okay, let's close and apply. Close and apply. Let's see. So create a new page, page 2. Same cluster column chart visual. Clustered column charts. So in this cluster column chart now, what we want to do is, let's see, it says manufacturing data, use the I print total employees column as the axis and first quarter payroll for the values. Okay, let's see that. So we want to use this I what's our I print total employees, I print total employees, which is this one here, and we want to use for the y-axis, we want to use the what do you want to use? The first quarter payroll. First quarter payroll. Oh, so we could say that these are employees with a following the range of 20, 40, 60. These are high range total employees. So what question do we want to answer now? So it now says, which is the second largest high range total employees category in terms of payroll? I think that should be 50. 50 is the high range, highest is what? Second largest is 40. That should be 40. We didn't pay attention there. 40. Yeah, we need awesome use of extraction power, although none of the extracted options are as powerful as using regular expression. They are certainly easier to use. Congratulations on finishing this chapter. So we nailed this chapter quite easy and quite interesting to see. We could nail that in order 40 minutes. We nailed it. That is interesting to see. I think the next chapter is on dimensional modeling. So dimensional modeling, which we are going to continue on day 30. Alright, so that will be the end of the live stream for today. So if you find value in this live streaming and trying to learn and master the Power BI data analytics tool like me, do want to support the channel by giving this video a thumbs up, like, comment, share your thoughts in the comment section, hit that subscribe button, put on your notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. So without any delay, I'll see you on day 30, which is tomorrow. Do have a wonderful night rest. Good morning, good afternoon, and good evening wherever you are. Bye.